Okay, here come the calculator instructions for what we just did manually. Okay, so we just finished filling in this table by using our formula over and over and over again. So now we're going to learn how to put this formula with this information into your graphing calculator so that you can get these values without doing all the crunching yourself. Okay, so here we are. I wrote it all out already. So we're going to do the same example again. So dy dx is equal to 1 over x. Okay, so this is just for this particular problem. And then we'll practice in class with the graphing calculator and some other problems. Remember, we do know a point on our function is 1, 0. That's going to be our starting point. And our h value, so our step value, how far over we're going to move on the x-axis each time is 0.5. So our x values are going to grow by 0.5. So the first thing you need to do is set up your equation. So here's Euler's method formula. And remember, in the formula packet, instead of saying dy dx, it says f of x comma y. But it means it's the same thing. We're just going to put our differential equation. It's going to go here. So now I'm going to fill it in with my specific information. So the starting y value plus 0.5 times the slope is going to be, whatever we had for our equation here is going to go in here. And now, though, when we put it into the calculator, we can't just put it in straight like this. The calculator wants it in a different form. So they are using different notation. So we are going to rewrite our equation. And when we rewrite it, basically what's going to happen is the x's and y's are going to change to u and v. So x is going to become the letter u, and y is going to become the letter v. We've used u and v before, but now we're using it in a slightly different way. And we're also going to be using like function notation. So instead of subscripts, these are going to basically be in parentheses. Okay, and also instead of using 1 and n plus 1, we're going to use n. This one's going to be n, and this one's going to be n minus 1. So slight differences. So I lined them up so you can see the differences. So like I said, y is going to become v. So instead of writing y of n plus 1, it's going to be v of n. And then instead of y1, it's going to be v of n minus 1. Okay, so you can see, this one is 1 greater than this one. And here in the orange, this is 1 greater than that one. Okay, in terms of like the step number. And then over here, instead of x of 1, we're going to be writing u of n minus 1. All right, but so it's just a little slight change in notation, but we're going to be using the same things from up here. We're going to be using our h value. So here's our h value, our h value, our h value, and our derivative. Here's our derivative, here's our derivative, here's our derivative. It's still 1 over x because u of n minus 1 represents x. All right, now when we enter this into our graphing calculator, one thing I want to point out is that each time we enter an n, all of these n's here, we're going to be using this button right here. Okay, we're going to be using the x t theta n, our variable. We're going to be using our variable button. So the n is the variable. The u and the v are right here above 7 and 8. That's where you're going to find the u and the v. So u and v are basically just labels, and n is the actual variable. Okay, so here are the directions right over here. Step 1, we're going to press mode. And then on the 5th line, here where it says function, if we go over, was that actually the 5th line? 1, 2, 3, 4, 5. Yeah, I think so. We're going to go over and we're going to select SEQ. Okay, there it is over there. And then we're going to press enter. Okay, next, we're going to press y equals. Normally when we press y equals, we get to like type in equations. But now that we've changed the mode, when I press y equals, notice, ooh, I get this weird thing. Okay, so here I've given you all the values over here in blue. Here's the values we're going to be putting in, and I'll explain them. It might be worthwhile to you to make some additional notes as to what the heck these all mean. So 0, n means our step. So remember when we set up our table over here, what was our first step? We called it step 0. So our minimum step, we're going to start with step 0. I don't know if that would ever change, if there would be a reason for changing that, but it's going to be 0. So if yours doesn't say 0 on your calculator, go up and change that to a 0. I know when I first turned on my calculator, it actually had a 1 there, but I had to change it to a step 0 because, I don't know, just because, so that it matches our table here. Okay, so we're going to change that to a 0. Then on the next line, where it says U of n is going to be, that's how do we get our x value? Remember, x is now u's. So how do we get our x values? We get our x values by taking the previous x value, that's U of n minus 1. So taking the previous x value and adding 0.5 to it. So you can think about that in terms of our table over here. How did we get the next x value? By taking the previous one and adding 0.5. Okay, so here on my graphing calculator, where it says the 3 dots U of n, I'm going to be typing in U, and we're going to be using the letter U here, which is above the 7. So I'm going to go second 7. See, that gets me the U. Parentheses n. Remember, for n, it's always going to be the variable n. So n minus 1, close parentheses, plus, and the 0.5, remember, that is our h value. So if you are doing a problem and they've changed the h value, make sure you change this, 0.5. Okay, so pretty much whenever you're doing a problem, you're always going to have this, U of n minus 1, plus, and then whatever your h value is. Okay, so you might want to make a note of that. All right, next, U n minimum. That means the point that you were given right here, this is our first x value. So what's our first x value? Our first x value is 1. Okay, so it's just that one right there. That's my UN min. And then for the next line, this is where I need this equation. It's asking me, well, how do we get V of n? V of n is y. Remember I said we're changing y's to v's. So V of n is equal to, and then we actually have to type in this whole mess. So we're going to type in this whole thing that we just set up using our formula. Okay, so I'm going to type in V. V is an alpha. It's use the second key, second 8. So there's my V, parentheses. N is a variable, n minus 1, plus 0.5, parentheses, because we're multiplying it, times 1 divided by, and then the bottom, notice, oh, I didn't do it here. Sorry. You should have the denominator all in parentheses. Parentheses, lots of parentheses. Okay, 1 divided by, to make sure that it all stays together, 1 divided by parentheses. I mean, it might work without it, but I'm not taking any chances. U, so I did second 7 to get my U, parentheses, n minus 1, and then close the parentheses. I think I need 3 of them to close it all together. Okay, and then my last thing I'm going to put in is my y minimum, and that comes from, again, my original point. So my original point was 1, 0, so this is 0. This comes from my original point, so I put in my 0. Okay, so that's probably something important to write down, that the V, these two numbers here comes from the 1, 0 in the original problem. Okay, that was like our starting point. Oops, I'm running out of room. All right, so you probably want to make a little note about that. That was given to us in the information in the problem. Okay, so I have all my information in there, and now all I have to do is hit second graph. And that's going to get me a table. So second graph. Thinking about it? Okay, notice I got all these errors here. I can't use any of these negatives because I told it to start with step 0. So I don't know why it even gives me all those little negative n's. I certainly didn't ask for them. I don't know how to get rid of them. But now I can go down and I can find any particular step number that I want. So if we look at this and compare it to our table, if we go back, because remember this was the problem we were doing before. So when x was 1, y was 0. X is 1, Y is 0. When X is 1.5, Y is 0.5. When X is 2, Y is 0.83333, repeating. And I get the exact same values as when I did it by hand, and it'll keep going. So say I wanted to find out the estimation for a particular X value, I can find it over here. Okay, and it looks like I could even probably like do something with value, but I haven't played around with that, but you can play around with that. We'll play around with that in class. All right, so there's your calculator instructions, and we will practice this in class, because if you don't practice how to do stuff on the calculator, you will never probably remember it on a test. All right, see you in class. Bye-bye.